In this video, I will show you how to solve some basic trig equations. We will limit our solutions to the interval from 0 to 2 pi. That's one turn around the unit circle. Throughout this video, I will be assuming that you have memorized all of the facts on this chart. For example, the sine of pi over 6 is 1/2. If you have not yet memorized the values on this chart, please pause the video and memorize it right now. To solve this equation, first we need to get sine x by itself. So we are going to add 1 to both sides. So we have 2 sine x is equal to 1. If we divide both sides by 2, then we have sine x is equal to 1/2. Now you ask yourself, what is the reference angle? The sine of what angle is equal to 1/2? And that's right off the chart we were just talking about. The sine of pi over 6 is 1/2. So that tells us that the reference angle is pi over 6. All right, that is not the final answer. That's just the reference angle. So, in terms of the reference angle, this location, this position on the left, which is pi, can also be thought of as 6 pi over 6. So there will be reference angles above and below this. All right, one position before 6 pi over 6 will be 5 pi over 6. And one position after 6 pi over 6 will be 7 pi over 6. Of course, this is pi over 6 itself. And way over here on the right-hand side, this would be 12 pi over 6. So that makes this 11 pi over 6, one position before 12 pi over 6. So the thing is, the sine of any of these four angles, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. The sine of any of these will give us some type of 1/2. It's just that sine is positive in the first quadrant and in the second quadrant, and sine is negative in the third quadrant and in the fourth quadrant. So since I want positive 1/2, then that means that the solution will be x is equal to pi over 6 and 5 pi over 6. Notice if this had been negative 1/2, well, then I would want the value to be negative. So I would pick 7 pi over 6 and 11 pi over 6, where the sine function is negative. Moving on to problem number 2. First, we have to get cosine theta by itself. If I add radical 3 to both sides, I will have 2 cosine theta is equal to radical 3. Dividing both sides by 2 gives us cosine theta is equal to radical 3 over 2. So what is the reference angle? Cosine of what angle is radical 3 over 2? Well, hopefully you will understand that the reference angle is pi over 6. All right, in other words, the cosine of pi over 6 is radical 3 over 2, and that's another one of these values on the chart that you need to memorize. Cosine of pi over 6 is radical 3 over 2. So the reference angle is pi over 6, but that is not the final answer. That's just the reference angle. Okay, so there is a reference angle in every quadrant. Over here on the left, we can think of pi as being 6 pi over 6. And over here on the right, we can think of 2 pi as being 12 pi over 6. All right, I better use a smaller ink. So just before 6 pi over 6, this would be 5 pi over 6. And after 6 pi over 6 would be 7 pi over 6. Of course, this is pi over 6 itself. And one position before 12 pi over 6 would be 11 pi over 6. We want cosine to be positive. This is a positive radical 3 over 2. Cosine is positive in the first quadrant and in the fourth quadrant. Okay, cosine is an x value, so it's positive on the right-hand side of the circle. So that's why the two answers will be pi over 6 and 11 pi over 6. So theta will equal pi over 6 or 11 pi over 6. All right, see the way reference angles work, the cosine of any of these reference angles will be either radical 3 over 2 or negative radical 3 over 2. Problem number 3. First, we have to get secant x by itself. So subtracting 8 from both sides, we have 4 secant x is equal to negative 8. Dividing both sides by 4, and we have secant x is equal to negative 2. Of course, we are much more comfortable with cosine than we are with secant. So let's do the reciprocal of both sides of the equation. So the reciprocal of secant is cosine, and the reciprocal of negative 2 is negative 1/2. So cosine is equal to negative 1/2. What is the reference angle? Well, the cosine of what angle is equal to 1/2? Ignore the negative sign for a second. Hopefully you know that is pi over 3. All right, it's right off the chart. Cosine of pi over 3 is 1/2. So the reference angle is pi over 3. So let us consult the unit circle. In terms of the reference angle, we can think of pi as 3 pi over 3, and we can think of 2 pi as 6 pi over 3. So there are 4 angles that have a reference angle of pi over 3. There's one in each quadrant. In the first quadrant, we simply have the reference angle. So in the first quadrant, we have pi over 3. But in the second quadrant, this is one position before 3 pi over 3. So this would be 2 pi over 3. One position after 3 pi over 3 would be 4 pi over 3. One position before 6 pi over 3 would be 5 pi over 3. The cosine of any of these angles will be some kind of 1/2. But cosine is positive in the first quadrant and in the fourth quadrant, while cosine is negative in the second quadrant and in the third quadrant. In this case, we want cosine to be negative. That's why the answers are 2 pi over 3 and 4 pi over 3. Problem number 4 will have an extra step because this is quadratic. It is being squared, so eventually we will have to deal with that. But first, let's get sine squared theta alone by adding 1 to both sides. So that will give us sine squared theta is equal to 1. So I need to get sine theta by itself. So I'm going to take the square root of both sides of the equation. When you do that, the solution will be plus or minus. So we're going to end up with sine theta is equal to plus or minus 1. All right, the plus or minus really matters, so don't forget it. Now, what is the reference angle? Well, that's kind of a trick question because this is actually going to be a quadrantal angle, so there is no reference angle. But you should be asking yourself the sine of what angle is equal to 1 or negative 1. So remember that sine is a y value, and if we label the coordinates of the points at each quadrant, this is the point 1, 0, and this is the point 0, 1, and this is negative 1, 0, and this is 0, negative 1. Sine is the y value. So we should be looking at the 0 and the 1 and the 0 and the negative 1. So we want the sine to be positive 1 or negative 1. So the two places where that happens is here and here. All right? The y value, the sine value, is 1 here, and it's negative 1 here. So up here at the top, that's pi over 2. So theta is equal to pi over 2. And down here at the bottom, this is 3 pi over 2. So these are the answers to problem number 4. For problem number 5, we first must get cosine squared x alone. So dividing both sides by 2, we have cosine squared x is equal to 1/2. Next, we need to take the square root of both sides of the equation. Don't forget, when you take the square root of both sides, the solution will be positive or negative. You know what? Some students get confused by this, so let me show an extra little step here. If I want to take the square root of 1/2, that's the same thing as taking the square root of the numerator and the square root of the denominator separately. So I'm going to end up with cosine squared x is equal to plus or minus. The square root of 1 is just 1. And then in the denominator, I have the square root of 2. I shouldn't have put this 2 here. So we took the square root of cosine squared. That leaves us a plain cosine. So that's better. So what is the reference angle? Let's go ahead and draw ourselves a unit circle. Cosine of what is equal to 1 over radical 2? Hopefully you're thinking, well, that is going to be pi over 4. So the reference angle is going to be pi over 4. And again, I'm pulling that right off the chart. The cosine of pi over 4 is 1 over radical 2. Okay, so the reference angle is pi over 4. There are 4 angles that have that reference angle. There's 1 in each quadrant. Since we can think of pi as 4 pi over 4, and we can think of 2 pi as 8 pi over 4, that makes this angle 3 pi over 4, and this angle is 5 pi over 4, and this angle is 7 pi over 4. And of course, in the first quadrant, it's simply the reference angle, which is pi over 4. The cosine of any of these angles will be some kind of 1 over radical 2. It's just that in the first quadrant and the fourth quadrant, we will get a positive 1 over radical 2. In the second quadrant and in the third quadrant, we will get a negative 1 over radical 2. Well, in this case, we want both the positive and negative versions. So really, all 4 of these will be solutions. So x will equal pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Problem number 6. First, we get tangent squared by itself by adding 1 to both sides. So we have tangent squared x is equal to 1. Next, we take the square root of both sides. So we will have tangent x is equal to plus or minus 1. The square root of 1 is just 1. Don't forget your plus or minus. Now you should be asking yourself, what is the reference angle? So hopefully you were thinking to yourself, the reference angle is pi over 4. The tangent of what angle is equal to 1? Ignore the plus or minus for now. The tangent of what angle is 1? So if you've memorized your chart like you're supposed to, you know that the tangent of pi over 4 is 1. So that's how I know that the reference angle is pi over 4. There are 4 angles that have a reference angle of pi over 4. There's 1 in each quadrant. So we can think of pi as 4 pi over 4. All right, I'm using the reference angle. And we can think of 2 pi as 8 pi over 4. So with that in mind, that means that this angle is 3 pi over 4, and this is 5 pi over 4, and this is 7 pi over 4. And of course, in the first quadrant, you get the reference angle itself. The tangent of any of these will give us some kind of 1. It's just that we will get a positive 1 in the first quadrant and in the third quadrant, and we will get a negative 1 in the fourth quadrant and in the second quadrant. Since we want plus or minus 1, we want all 4 of these solutions. So x equals all of the pi over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.